Welcome back to our second part of this video series. If you didn't see the first video, you may want to loop back and watch that now. In this video, we're going to do some time traveling and go super heavy on the nostalgia. If you've gotten to x86 virtualization or networking in the early 2000s, be prepared for a journey down memory lane. For those who didn't experience the beginning of this renaissance in technology, don't worry, I'm going to go over all the fun and interesting history we have time to cover. First, let's level set. It's 2005, the days of mainframe are over, and you have started to accumulate a lot of x86 servers in your data center from your favorite server provider. The AS400 is in the corner somewhere, still doing whatever an AS400 does. What was once a lot of space and open RU in your data center is no longer looking like a ton of space. Enter VMware. I'm not going to do the history of Type 1 hypervisors versus Type 2, but around 2000, the first Type 2 hypervisor from VMware hit the market. VMware GSX was the first designed for the enterprise server environment, but as a Type 2, it was limited. In 2004, VMware came to market with their first Type 1 hypervisor, ESX. It sounds crazy to say, but ESX is coming up on its 20th birthday. VMware ESX followed closely in creation by its management platform vCenter, brought all kinds of new technical capabilities to the enterprise IT environment. Most importantly, vMotion, or live migration of workloads between physical servers. To anyone doing maintenance or operations, this was game-changing. Circle back to our shrinking data center space, enterprise IT started to ask themselves hard questions. Are my physical servers really providing all the performance I paid for? The answer was overwhelmingly no. The average 2-socket x86 server in 2005 was using around 8% of its paid-for capability. VMware was quick to point out they could help customers see 70+% utilization on their physical servers. Combine the operational capabilities of ESX and vCenter with the potential cost and space savings, and adopting virtualization was a real no-brainer. Like all new technologies, there were discovered challenges that were unexpected as adoption of virtualization took place. Network teams could no longer see traffic all the way to the operating system. Network data disappeared into virtualization hosts with virtual switches. Virtual switches back then didn't provide much more functionality than an unmanaged Layer 2 switch, and data center networking teams were not happy. As much as virtualization saved time, money, and space, it also challenged traditional IT design and operations. Speaking about networking, virtualization had possibly a greater impact on the network than it did on the server. Something not always associated with x86 server virtualization is VLANs. VLAN networking was introduced in 1999, just before server virtualization busted onto the scene. While preceding server virtualization by a few years, these two technologies grew up together and complemented each other extremely well. They also experienced a lot of the same hesitancy that x86 virtualization received when talking about mixing workloads or data that would traditionally be air-gapped or on different physical hardware. Virtualization, both server and networking, challenged a lot of set-in-stone operational security practices. Talking about technology that spans a 30-year time frame can be confusing. If we think about everything we've covered so far in this video as the birth years of virtualization, then 2010 to 2015 are the teenage years of virtualization and the beginning of software-defined. Like most concepts, software-defined storage has been around for a long time. My first experience with it was for our corporate lab in 2005. Being on a startup budget, free licenses from friendly partners were always welcome in the lab. Supermicro server and code in hand, I built the entire corporate lab. The corporate lab back then was used for training and demonstrations. There was AD, SQL, and a lot of Citrix and VMware. Unfortunately, the software-defined storage had a habit of imploding. That meant I got to recreate the entire lab from scratch multiple times. I am definitely the VMware and Citrix engineer I am today because of how many times I rebuilt that lab. I owe software-defined storage a piece of my career. Fortunately, by the time 2010 rolled around, the concept of software-defined storage was much more mature and integrated. While software-defined storage didn't start in 2010, that was when it became mainstream enterprise, in my opinion. The following years saw further refinement, larger install bases, and more integrated features of traditional storage. As we sit in 2022, software-defined storage is one of the elder statesmen of software-defined. It also is a key underpinning of the cloud. Not to be outdone, its bigger brother networking also went software-defined in 2011 through 2015. The success of SDN led to it expanding beyond the LAN and onto a much more impactful space, the WAN. SD-WAN has been a key network technology for the last 5 years. It has changed how and what type of WAN circuits are used. Network traffic and redundancy have paths of last resort that wouldn't have been possible 10 years ago. I'll save the rest of the SDN and SD-WAN deep dive for a future video. Needless to say, not only are they key to cloud, but right now, they're one of the more innovative parts of it. These are the components that make up the backbone of the cloud. As you dive deeper, while complex, it becomes clear that the cloud is, after all, based on very mature and tested technology. I encourage everyone to watch the next video where we'll jump into the concept of data gravity and how it drives your cloud architecture without you knowing it.